Welcome back. So we've seen arrays and we are now going to look at methods. Methods for the past week or over a week, we've been looking at methods. And here is just a few things that if not for the lockdown and we were going to write a test, those things you would have to learn them, memorize them, and come and write a test, because a part of the test would have been a theoretical part. But now that all of that is off, so these are things you have to read and understand by yourself. It's good to complete your knowledge. So a few of those things I'll touch on them now. The other things I'm going to ask you to go ahead and read it. Meaning I'm going to put it as part of your reading for Unit 2. All right. So methods, again, you see what methods is. It's like a small program. It's like a function in Python. It's a part of your program that is isolated. Sometimes it returns a value, sometimes it doesn't. Why do you have to use methods most times? Obvious reasons, like you want to avoid code duplication. It allows you to structure your code. The code is more readable if you use methods. And you can also reuse some code fragments. Let's say you have methods that are applicable in different projects. You can copy them around. And how to declare methods, of course, we've seen that over the last. Static is optional. When it's static, you don't need to create an instance of that class to be able to use that method. All right. But when it's non-static, meaning that you don't put static there, then you have to create an instance of that class to be able to use that method. All right, return type, all of those things, you've seen many examples of it, so I'm going to leave that for you. Examples of methods, of course, you've also seen all of this. We've seen main method, we've seen factorial method. These are good naming, so when you're naming your method, be sure to name it well. Capital letter to start in the method name is better, preferred to small letters. And here you can see that some methods are badly named because you see you cannot tell what the method does by just looking at the name. And there's what's called access modifiers. Modifiers are the prefixes you put before you define methods, like things like static, public, and private. And some modifiers are public and static. So I want you to read about these things. Here is a text that describes the difference between all of these different modifiers. So be free to read through those things. You're not going to get tested on them anyway. So, however, sometimes when you're debugging and you forget that you've made a method private and you're wondering why it's giving you an error, is because the method needs to be public. Sometimes you're calling a static method from a non-static one. So that could also give you some errors. So when you read this, it gives you a good picture of what that is all about. Invoking a method, you just call the method name, you pass the parameters to it. If it's a method with a parameter. If it doesn't have parameters, you don't have to worry about it. So yes, very simple example. Again, we've looked at many examples, and in previous videos I've shown you many examples of similar things. You can type this code and just test it out and see how it works. When they have parameters, a method can have as many parameters as possible. You can also have diverse parameters. You can have integer parameters, string parameters for the same method, depending on what you're trying to do. So we've seen all of that. And methods in the same class, I've shown you that. Method in another class, we haven't seen that. So that I'm going to show you now. And method that returns an object, I'll also show you that. And void methods, of course, you've seen that. So let's start with this one. Method in another class. So let's say we have another class. So if you observe closely, you realize that everything we'll be writing is in the main class called program. One thing that we can do from your Solution Explorer is to drop another class in this class. All right. So classes allow you to organize your program. So I can say add a new item, can just say class. All right. And I pick my class there and I specify the name of the class. So I'm going to call this class factorial. Why would I want to do this? Because I'm thinking I could have a separate class to calculate factorial and factorial things like combinatorial analysis, whatever I want to do regarding factorial, I'll put it in this class. As this class is right now, I may want to make it accessible more by making it public. All right. So public make accessibility even better to other projects within this namespace and other namespaces. So please read about those texts so that you can understand what I'm talking about. So that's a class there, and I can put a method in this class that calculates factorial. So I'll call it public. static. All right, here I will show you exactly the difference between public static and non-static classes. All right, let's call it get factorial. All right, it's gonna return an integer anyway, so return type int. Let me call it calc. All right, because I'm already in a factorial class, so I can call it calculate. All right, meaning that I'm calculating factorial. And factorial reads n, and n is an integer, and that's done, declared. All right, this is underlined right now because anytime you say there's a return type, it's going to wait for it to return something. So again, everybody knows our factorial algorithm. I'm not going to waste time on that, so I'm going to say int I equals 1, and I'm going to go for, let's just say factorial is 1. Then I'm going to go for int I equals 1. I is less than or equal to n, that's I plus plus. All right. And because I have only one line of code, so I can just continue here like I described to you in previous videos. Multiply equals I, and that's it. Then I will have return factorial. All right, done, job done. That's our method right there. So we have a method called calculate. Again, let's look at it. It's a static method, meaning I don't have to create the instance of this class to use it. Now I'm going to show you how that is different. If I remove static, the class will still be fine. In fact, I can remove public. The class is still fine. All right. But this class now is only, this method now is only usable in this class. All right. If I put private here, I can put private. It's also usable only in this class. All right. But I'm going to go back to those options I have, and public and static. All right. So we leave it the way it is now. And I'm going to go back to the other class. So this was the class. It's still in the namespace, as you can see. I'm just calling this copy paste code because that's the initial name I gave to my project. Then I'm going to go back to the other class. As you can see, the other class is up here. All right. Then here I'm back to my main method. All right. So the previous examples from previous videos, I'll just comment them out. I know we've had a lot of commented stuff. So if I want to call this method in this class, so this is the class factorial, all right? If I want to call calculate, and I want to give it an n, and it's going to return a value back, how do I proceed with that? I will mention the name of the class, which is calculate, which is factorial class, you see, dot, you can see it gives me an option of calculate because it can see the method there. And that's because method is static, all right? And it's public at the same. Public, I can access it. Static, I don't have to create an instance to be able to access it. So I will say calculate, and I can give it a value 4. So, and for this to be displayed, let me just create a variable called answer, because that, and let me display the value of that variable. Answer. All right. So what I have done here, if calculate was a method in this class, I don't have to call factorial class. However, I'm calling factorial class that's right here, and I'm saying dot, meaning in this class dot what? What is in this class? So if you open the mouse around, you can see it also shows you it's a class. That little icon there, that orange icon there, that like orange icon of stuff is class, and this one is method. Methods comes an icon like it's like a box, like a purple box. All right. So let's see what we get from that. As you can see, the answer is correct, 24, because 4 factorial is 24. All right. Now I'm going to now show you the difference between the static and non-static by going back to my method and making it non-static. So I'll come back here, I remove the static, the method still works fine, but now I'm going to have to struggle to locate this method. So when I go to main, again, you see the method now is being underlined as a prop. So you can see the comment says an object reference is required to non-static field methods, properties, or anything. So So something is not static, you need an object reference. You need to create an instance of that class, which is called an object reference. How do I do that? Let me show you quickly. So how you do that is, sometimes you want your method to be non-static for whatever reason. But if you want to make reference to them, still can do that by using the class. I can call my factorial class as factorial f equals new factorial. All right. So what I've done now, I've created an object of that class. So f now is an object that represents this class called factorial. And it's a new object. And instead of calling factorial straight up, because calculate is not accessible, it's non-static, I will now use f to access it. And now it's going to work exactly the same thing. I'll say f dot calculate. So it sees f as a separate class and then checks and goes. It gives me access to all of the non-static methods inside f. And f in that case represents the factorial class, and this class, this method is non-static, so that works. Now, I kept saying earlier on that this thing here is creating an instance of that class. You see, f is an instance of this class, and that's an additional line of code. So if you don't want to put a line of code in there, it's better you make your method non-static. Like I comment out this guy, and I come here and I'll make this method non-static by calling it static. Then when I come back here and I say factorial dot that, then everything is perfectly okay. All right. So we've seen factorial dot calculate, method that return objects that I will show you now, and void methods. You've seen many of that. So let's return an object. All right. What does an object mean? You can write a method that returns a whole object. So an object is an instance of a class. So here's an example of a class. All right. And this whole class, I can wrap it into an object called f here, as you can see. All right. So if I were to create another class, let me just quickly do that. Add new item, or not new project, from place. Okay, I'm clicking the solution, that's why it's giving me the option, and to click the project. All right, so new class. All right. So the class, let's call this class student class for whatever reason, student class. All right. That's our student class. Again, I want this class to be accessible. So first I'm going to do, I make it public. And I'm in a student class. Let me add some attributes to the student class. Student number, for example, is a string. So student number, I can add some variable. And let's say age of the student is an integer, age. All right. And let's say this is a class. And again, don't forget there's another chapter coming on object orientation. I'll explain to you. Just that now I have to show you a method that can return an object. All right. So this is a student object. All right. So assuming that I have this method here in this class that takes a particular student, which is the student number and the age, and increments the age by 5. So what is that method going to look like? Public, static. It's going to return a student. So I'm going to use, instead of saying, okay, student. All right, so it's going to return a student. So the return type is student. And the name would be, let's say, increase age. Increase age. All right. All right. And it's going to take a student. So we'll say student, a student. That's our variable name. All right. Explaining again, here's just a static method in the student class. What does it do? It takes a particular student, all right, called a student of the type student. So as opposed to int, float, double, all those are called primitive types. You can actually have your class as a type, all right? Meaning that this is now an object, it's an instance of this class. Everything that's possible in this class is possible with this variable now. That's what we are talking about. But we're going to get to object orientation and explain to you further. So a student of type student, it's going to return type student, but when we get this student, what do we want to do? We want to increase the age of that student by 5. So a student dot, now you can see I have no access to the age, even though the age is here. So what I have to do is to make this public, and when I say dot, you can see now I have access to the age. Dot age equals, okay, plus equals 5. All right. So what I'm saying is, okay, so because a student is returned in this circumstance, I have to make sure that my return is actually a student. So I'm going to create another student. I'll just call it return equals new student. All right, that's it there. That's our new student. So our new student is going to return, I will say dot, the age now of that person should be plus equals 5. Then I will return that object. All right, that's it, done. So increase age student, public, let me just see why it's still underlining. Okay, because you see it's complaining that this method, we are putting it inside the namespace as opposed to inside the class. So I'll just put the method in, of course. That was just a mistake on our side. So this method has this class has these variables, and there is a method that takes a student and then returns another student. So now here you've seen a method that can take a whole object. All right, and that's what I wanted to show you when I say methods that return objects. So this method takes an object and returns an object. Again, when we get to object orientation, we're going to have a lot of time to talk about the modalities of how these things work. So in the next video, I'm going to discuss recursion with you. See you on the other side. Boom.